Assalamu alaikum. My name is Abdullah Ajmal, and today I will be explaining my DLD semester project, which is line follower robot. So first we will move towards the introduction of a line follower robot. So basically, what is a line follower robot? A line following robot is a self-sufficient robot which can follow either a dark or white line that is drawn on a surface composing of contrasting colors. It is intended to move consequently and follow plotted lines. The robot utilizes a few sensors to recognize the line consequently, helping the robot to remain on the track. The user the use of four sensors makes its development exact, adaptive, and flexible. So, for this project, the criteria that was given to us included one user-defined case and all other simple cases. So basically, the user-defined case included that whenever our robot reaches a T-junction, it should sense it and stop at that particular point, and it should always follow the black line and or should always remain in between the black lines and do not fall behind or above the black line. So research and paperwork, I will move towards the paperwork which was done by myself. So basically we have four sensors: left sensor, center one sensor, center two sensor, and right sensor, and we have two outputs for left motor and right motor. When all of the sensors are detecting zero, which stands for black line, so none of the motor is working, which means that this is our user-defined case, which includes the point when the T junction is reached and the body stops. So when we have 0, 0, 0 and 1 on the right sensor, only the left motor will be moving and the right motor will be 0. Similarly, the respective cases are carried on when we have so basically the truth table was designed so whenever our left or right sensor is on with respect to the central sensor, even if they are on or off, the respective opposite motor will work. So for example, if the right motor is detecting 0, right sensor is detecting 0, and center sensor are also detecting 0, so our left motor will work and move the robot in that specific direction, irrespective whether the center sensor are on or off. When both of the center sensor are detecting a line and both of the left and right sensor are detecting white surface, our robot will move in a straight line. So basically I implemented this whole uh, um, project using two approaches. One was K method and simple gates. So for left motor we have this particular K map, and this is the equation for left motor, and this is the circuit diagram which includes 3 AND gates and 1 OR gate. And for the right motor, this is the right motor K map. This is the equation, final Boolean algebraic equation, and then we have the circuit diagram which contains 3 AND gates and 1 OR gate. So similarly we can apply rudimentary logic. So we were not restricted by our professor whether to use gate level implementation or go for complete optimization. So I went for complete optimization. So basically in complete optimization I used rudimentary logic on the output based on one single input, and the other inputs will work as signal inputs for Muxis. So basic rudimentary logic was applied by making a pair of 2 bits and making equation for particularly each output on the basis of one input. The input on the basis of which the output was mapped was the right sensor input. So these were the equation for the left motor and for the right motor operations. So this is a mux implementation where one is permanent one, L is the left sensor, only this sensor, the L, C1 and C2, center 1 and center 2, and the left sensor are used as signal inputs A, B, C, and the right sensor R and this inverse R dash are used for the inputs as data inputs for our muxes. So the muxes that we have used here are low enable muxes. It means that whenever we give them 0 on enable point, they will work fine. These are our motor connectors and this is the ground connection point. So Now let us move towards the software implementation of the circuit. So this is the software implementation of the circuit. So basically this is the Mux-based software implementation. I also have the gate-based with the complete truth table and all of the above stuff included into it. So let us run this simulator circuit. So then both of the central sensors are on. Our robot will move in forward direction. So let me just turn on the right sensor so that only our left motor will work and move the robot in specific direction. Now turn off the right sensor and now turn on the left sensor and keep this permanent one. So basically for this again now only our right motor is working, the left motor has stopped working because it will move in the respective direction. Now for the final condition, when our junction will be reached, all of the inputs will be 0. So when all of the inputs is 0, our robot will stop when it is detecting 0 line. So basically the working of the robot depends upon our infrared or IR sensor. So basically there are two type of IR sensor. One are those type which give complete output when they are detecting 0, and one give complete output when they are detecting 1. So the ones that we used in our project were that those sensors which were giving complete output on 0 while detecting black line, and they were giving very minor amount of output when they were detecting contrast or white areas. So now let us move towards the PCB layout. So this was the PCB layout that was created. Our group's name was Dothraki. So basically the basic goal for a PCB design in a single layer on this level is to reduce or minimalistically use jumper wires. So the number of jumpers that we used was totally 4, and the gap was very low, so there was no such loss and any other thing. So we can also see the 3D visualizer view of our PCB. So it looks something like this. So this is a 3D view of a circuit. So basically we have also implemented the reverse current protection to protect our ICs from reverse current from the output, and to also to control the rotation of our motors so they do not rotate in the anti-clockwise direction to move the robot in backward. So only our robot will only move in the forward direction, not in backward direction. So that is from the what we say software side of our. Now let us move towards the hardware side. So basically we included a 12 volt battery for powering the motor driver circuit and for the motors, so that they can drive normally. So the motor that we used was the code name was 6DC G12. So basically this motor works on 12 volts and produces 200 rotation per minute with a gear reduction ratio of 32 to 1. So that can produce 1.3 kilogram per meter square of torque. These were the jumper wires. So basically we implement our circuit wise. First was the rough implementation using breadboard and jumper wires and our ICs. And the second implementation was after etching up a complete final PCB, soldering our final components onto it, and then finally testing it onto a track. So basically this was the breadboard jumper wire. This is LM29 3D. Sorry, L29 3D, which is a motor driver which has attributes built into it. So it is not like what they call a PWM operator, because it only includes attributes on it only, and it only controls the direction of motion or direction of current, which controls the direction of rotation of the motors. So basically in this controller we have 4 enables, enable 1, enable 2 for one motor, and enable 3 and enable 4 for the second motor, and 4 motor outputs for controlling one motor each. So these are our muxes. So the IC number of our mux is 74151, which is 8 plus 1 mux with active low enable, and the second IC that we used was a single NOT gate, which was 7404 to implement it with our right sensor. So basically this is our robot base, which is made up of acrylic, having these are our special motors that give a 32 to 1 of the gear ratio. giving us sufficient torque to move. This is the Vero board on to which we mounted our sensors. So this is the complete robot with mounted. These are the sensors. These are HW201 sensors based on an amplifier based technology and a and a potentiometer to adjust the range and sensitivity of the sensors. So basically this is a soldering operation that is being performed onto the printed PCB. This is a drilling operation that is being performed on PCB. So this was our PCB board when the toner was shifted onto it. This was after the etching procedure, only the traces were left after etching. So this is our circuit after what we say. This was the first testing of our circuit based on breadboard, and now let us see what the explanation was given.
ये हमारा लाइन फॉलोइंग रोबोट है और इसके अंदर हमने 4 आईआर सेंसर्स यूज़ किए हैं, 2 मक्सेस यूज़ किए हैं जो कि 8x1 है और एक नॉट गेट यूज़ किए। ये हमारा मोटर ड्राइवर है और ये रोबोट चेसिस और ये 2 व्हील्स हैं। और अगर यहाँ पे हमने 5 वोल्ट की इनपुट दी है और साथ ग्राउंड किया हुआ है और यहाँ पे अगर चारों सेंसर्स की वैल्यू जो है वो 0 है तो रोबोट के दोनों व्हील्स स्टिल पे। और अगर मैं सिर्फ राइट सेंसर को ऑन कर देता हूँ यहाँ से, और इस वक्त अगर आप देख सकते हैं कि लेफ्ट मोटर ऑन है और लेफ्ट व्हील रोटेट कर रहा है, यानी कि ये लेफ्ट से राइट की तरफ टर्न करेगा। और अगर मैं राइट को फिर ऑफ कर देता हूँ और इस बार लेफ्ट को ऑन कर देता हूँ, अब आप देख सकते हैं कि सिर्फ लेफ्ट वाला ऑन है और बाकी C1 C2 और राइट ये सारे ऑफ हैं। तो आप देख सकते हैं कि राइट मोटर टर्न कर रही है जिसकी वजह से ये लेफ्ट टर्न कर होगा। और अगर मैं लेफ्ट वाला भी ऑन कर देता हूँ और साथ C2 भी ऑन कर देता हूँ तब भी ये मूव करेगा लेफ्ट की तरफ, मतलब ये राइट टर्न करेगा क्योंकि सॉरी लेफ्ट टर्न करेगा जबकि राइट मोटर मूव कर रही होगी। लेकिन अगर C1 और C2 में ऑन करता हूँ तब ये दोनों मोटर्स मूव करेंगी। एक ऑन है और बाकी दोनों ऑफ हैं, लेफ्ट और राइट। तो अब ये दोनों मोटर्स रोटेट करें जिसका मतलब है ये स्ट्रेट मूव करेगा।
So this was our testing of a circuit for the first time on the breadboard in DLD lab. So this was the first time after making the PCB we were testing our circuit with only 3 sensors because we were having an issue with our fourth sensor placement because of the interference of the sensors IR radiation with each other. So at the end of the project we made necessary arrangements. So we inverted the direction of the two center sensors C1 and C2, so the infrared radiation from each other could not interact with one another. So I will also show the final demonstration of the project.
इसका बहुत बैकग्राउंड वीडियो बहुत एडिट करनी पड़ी यार इनका वो जो इन्होंने वीडियो बनाया।
Three sensors. So basically this was the final working of our project in which all of the 4 sensors were working properly and it was following the line properly without any interference from outside sunlight or light or infrared radiation from other sensors.
ये ना बड़ी कॉस्ट कर रही है बीच में
कुछ नहीं होता है
क्या ये जोड़ेगा क्लियर द ट्रैफिक ब्रो
नाइस
आगे डिसीजन है
सिर्फ आगे कुछ नहीं हो जाता।
So this was the final demonstration of my project. So basically the issue that we faced during our whole project was that one was that the IC chips that we were using were heating quite a bit, so we used IC bases to reduce that, so there was ample airflow beneath the IC, so they were cooled down a bit. And the second was the issue that I discussed earlier was the interference of infrared radiation between the sensors. So it was reduced by changing the direction of placement of IR radiation from the sensor module. So that's all from my side. I have also provided the sufficient material in my video description, so anyone in need of the any guidance according to this project, can also leave a comment, and the files are shared with you in form of Google Drive links. So thank you for watching. That's all from my side.